Hello everyone. Section 10.6 segment relationships in circles. Example 1. We're going to multiply x times x plus 6 is going to be equal to x plus 1 times x plus 4. It's going to require you to remember some of your Algebra 1 material. Distribute the x. Left side's pretty easy. X squared plus 6x equals. Double distribute here. X times x times 4. We're going to get x squared, 4x, 1x, plus 5x, plus 4. X squareds cancel, subtract x squareds from both sides. Subtract 5x from both sides. X equals 4. It's asking for the length of AB. So if x is 4, then this is 10. So AB, segment AB has a length of 14. And PQ, if this is x plus 1, so this is 5. And this is 8. So PQ has a length of 13. There's example 1. Example 2 revolves around this theorem, the segment and secant's theorem. So I'm going to be talking about PQ as the external part of the secant, and then PR is the entire secant. So, example 2. Example 2. 4 times x plus 4 is equal to 3 times 3 plus 9. 4 times x plus 4. So the external part times the entire secant is equal to 3, the external secant, times the entire secant, which is 12. So I'm going to divide both sides by 4. X plus 4 equals 9. And x equals 5. Example 3. I know we have another theorem about secants, segments of a secant, and a tangent theorem. But really, if you just think of tangent as the external part and the entire part being the exact same thing, that's how you get wx squared. So x squared is equal to 12 times 12 plus 13, 27. X squared equals, I'll grab my calculator here, 12 times 15, sorry, 12 times 27, 12 times 27 is equal to 324, which is probably going to be a nice perfect square root both sides. X equals 18. So x happens to be wx, which is what we were looking for. Okay. Example 4. 1 times 1 plus r plus r. 1 times 1 plus 2r equals 3 squared. So 1 plus 2r equals 9. 2r equals 8r, which is the radius of the circle, is equal to 4. Example 5a. X times 5 is equal to 3 times 7. So 5x equals 3 times 7. 5x equals 21. X equals 21 over 5, or 4 1/5, 4.2. Part B, 8 times y plus 8 equals 15 squared. Y plus 8 equals 225 divided by 8. 225 doesn't divide evenly by 8. But we get y plus 8 equals 28.125. Subtract 8 from both sides, and y equals 20.125. That's example 5. B, example 6a. Now we've got 3 times x is equal to 2 times 12. 3x equals 24. X equals 8. Okay. X squared is equal to 6 times 24. X squared equals 6 times 6 plus 18. I'll write out the steps for you. X squared equals 6 times 24. 6 times 24. X squared equals 144. X equals 12. And part C is the first time we run into a problem that's a little bit tricky. Okay, now what we could do is we could give this a new variable and call this 10 minus. So if we call this y, we can call this 10 minus y. And we can use this product theorem up here to calculate what y is, and then use Pythagorean theorem. But there's actually a quicker way, and that is to draw in this radius, which we know is 10. If this segment's being bisected, which it is, then that's a right angle, which makes this 6. 6, 8, 10. If this is 6, the whole thing's 10. This is 4. This is 4. This is 8. This is x. Pythagorean theorem. X squared equals 16 plus 64. X squared equals 70. Is that 80? X equals square root of 80. So let's see what we got. 2 times 40, 2 times 20, 2, 4 square root. Square root 5, I think. I'm trying to do it in my head. Probably shouldn't. 80. It is. It's 4 square root 5, which is, let's see, square root times 4, approximately 8.9. Let's see, 80 square root, about 8.9. So x is approximately 8.9, which I believe the answer key has a wrong answer. Now, I'm going to use the same idea for 7. Again, they want us to draw the whole circle. And what they want us to do is make a variable for this be y. Actually, it wouldn't even be y, because the whole... Actually, I'm going to do it that way. I was thinking about doing the radius and doing the Pythagorean theorem like we did here. I'm actually going to make this easier. If the whole radius is 125, then the diameter is 250. This is 50. This is 200 feet. 200 times 50 is equal to x times x. X squared is equal to 50 times 200. And if we square root that, we get 100. So x squared equals 10,000. X is equal to 100 feet. And the shortest distance from A to B is going to be 200 feet. So the length of segment AB is 200 feet. All right, that was 7. Example 8. We want to find the diameter of this circle, and we're going to do that for part B too. 6, 8, and x. So 6x equals 8 times 8 is 64. And x is equal to 64 divided by 6, or 10.7. Repeating, that rounds. But we're looking for the entire diameter, so 10.7 plus another 6, so the diameter is going to be 16.7. 0.7. Okay. We're going to do a little bit of extra drawing here. Right angle. That's going to have to be a 5. 5 blank 13. Diagonal triple. 5, 12, 13. We need to find this little piece here. X. 12x equals 25. X is equal to 25 divided by 12. 2.083 repeating. And we have to add that to the 12, and we're going to round to the nearest tenth. So 12 plus this is going to be 14.1 when we round it to the nearest tenth. Example 9. Find the values of x and y using the different theorems. So I'm going to find the value of x first, and I'm going to use that value to find the value of y. Although I don't need to, I can find y directly, and we could see that when we do this. When we do example 11, we don't need to do it the way that I'm going to do it. We just find the x first. So x squared is equal to 4 times 4 plus 16 is 20. X squared equals 80. X equals 4 square root 5. And we're going to round that to the nearest tenth, which we did that earlier. I think it was 8.9. Yep. So it's approximately equal to 8.9. So that's x. We're going to use that to find the value of y. Do I want to do that? I'm going to. So I'm going to do that to find the value of y. But I'm going to use the 4 square root 5 or the square root of 80 to do it. So we've got square root of 80 squared is equal to 8 times 8 plus y. Square root of 80 squared is equal to 8 times 8 plus y. 80 is equal to 64. Actually, I'm just going to divide both sides by 8. 8 plus y. 10 equals 8 plus y. Y is equal to 2. Okay, now what's the other way that we could do that? 4 times 20 has to equal 8 times 8 plus y, because they're both equal to x squared. So I could have found y directly by doing 8 times 8 plus y equal 4 times 4 plus 16, which is 20. Essentially, that's what I did. Just broke it up into 2 steps. Okay, part B. Here we have a 5, because this is a 5. Because this is being bisected, right? A diameter bisects the arc and its chord. That makes this a right angle. So since this is a right angle, 5 blank 12, it would be nice if this was a 13. 5, 12, 13, but it's not. We saw that in a previous problem. 5, 12, 13. Where did I go? Oh, right above it, right here. 5, 12, 13, and we would have been able to find the x that way. But we have to do Pythagorean theorem. So we have 145 squared plus x squared equals 144, or 12 squared, 25. X squared equals 144 minus 25, 119. And we square root that. X is equal to 10.9 approximately. We can use the value of x to find the value of y. So we have 10.9, or square, you know what? I'm going to write x square root of 119 equals 5 times 5, or 25. So x is equal to, because we can use our calculators for this, 25 divided by 119 square rooted is equal to 2.3. Sorry, not x, y. Again, I think the answer key has a slightly wrong answer on it for both x and y. So that was 9. 10 is filling in the proof. Okay, so problem 10. We're going to complete this proof of the segments of secants and tangents theorem. So we know that secant segment PA and tangent segments PC are drawn in this circle from point P. Okay. We're going to prove that R, which is the length of PA, the entire secant, times S, the external part of the secant, is equal to T squared. Okay. We're going to draw chords AC and BC. How do we know that? 2-point postulate. So any 2 points is exactly one line. How do we know that the measure of angle A is equal to half of the measure of arc BC? Well, angle A is an inscribed angle. So it's the inscribed angle theorem. Okay. arc, the measure of angle BPC is also equal to half of arc BC. The measure of an angle formed by a chord and a tangent is half the measure of the intercepted arc. Okay, another one of our theorems. Therefore, the measure of angle A is equal to the measure of angle BPC, or substitution or reflexive property. Go with substitution property. Okay. Angle P is equal to, angle P is congruent to angle P, reflexive property. So we have this angle and this angle are congruent to each other. This angle is congruent to itself. I originally said BCP. I said the letters wrong. This angle cuts off this arc. This angle cuts off this arc. They're congruent. Angle P is congruent to itself. Therefore, these two triangles, triangle CAB is similar to triangle CPB. CAB, I want to make sure I get these letters right. No. Angle A, triangle APC is similar to triangle CPB. So APC is similar to triangle CPB, and that's angle similarity theorem. Got a slight mistake on the answer key. Now, because we have these triangles similar, we have ratios that are going to be proportional. So, and we want to get the correct ones. So let's get R, which is the whole side, which is AP, matches up with AP matches up with CP. AP from this triangle matches up with CP in this triangle. And PA, no, I did that one. PC, sorry, PC, did that, matches up with PC in this triangle, matches up with PB in this triangle. Or, using the letters, we got AP is R, CP is T, CP is T, and PB is S. And that's corresponding parts, sides, sides of similar triangles are proportional. Corresponding sides of similar triangles are proportional. Cross product property, T squared is equal to R times S. So cross product property to a means and extremes property. Cross product property. Or means and extremes property is another name for that same property. That's example 10. Example 11 is we're going to do a proof that UV times UW is the same as UX times UY. We know that these two circles are tangent to each other, so that makes UT a tangent line at point T. Okay, so let's do statements and reasons over here. Statements, reasons. 1, rewrite the given. 2, UX times UY, UX times UY is equal to UT squared and similarly UV times UW is equal to UT squared again. And that reason is the segments. Let me make sure I get the name right here. Segments of a secant and tangents theorem. Segments of a secant and tangents theorem. Okay, and then statement 3, UX times UY is equal to UV times UW. Substitution. Property. QED. Demonstratum. Example 12. PT is tangent to the circle. Find the lengths indicated. Okay, so PT is 6. PB is 3. We want to find the length of AB. So off to the side here. 3 times AB plus 3 is equal to 36, or 6 squared. AB plus 3 is equal to 12. AB is equal to 9. 1. Okay. PT is 12 this time. CD is 18. PC is what we're looking for, the entire length. So I'm going to now leave it as PD. Okay. So we have PD times PD plus 18 equals 144. Okay. Distribute the PD. I'm going to make this a y. So y squared plus 18y minus 144 equals 0. And then we're going to have to factor this. Let's factor y plus 24 y minus 6 equals 0. So y equals negative 24 or positive 6. But since y represents a length, then PD can only be 6. Can't be negative, which makes PC 24 for a length. All right, part C. Get rid of these now. PD is 5. CD is 7. AB is 11. And we're looking for the length of PB. I'll call it X, although this time, nope, I will need it. It'll make things a little bit easier. So X times X plus 11 equals 5 times 12. So X squared plus 11X minus 60 equals 0. And again, this is going to factor. 4, 12, 4, 15. X plus 15, X minus 4 equals 0. X equals negative 15 or positive 4. Again, since X represents the length of a side, PB, it must be 4, can't be negative 15. Okay. Last one, part D. Okay, PB and AB are both 5. 5 and 5. PD is a 4. We're going to look for PT, call that X. And we're going to look for PC, we'll call this Y, and we'll call PC Z or whatever. We'll just leave it as PC. Okay, so let's find X first. When we head to the side, X squared equals 25 times 10. 5 times 10. X squared equals 50. So X equals 5 square root 2, which is the length of PT. 5 square root 2. Okay. PC is going to be, let's use the 5 and the 5 again. So we have 4 times y plus 4 equals 5 times 5, 5 times 5, or 5 times 10, sorry, 5 times 10. 4 y plus 4 equals 50. Y plus 4, let's go 4y plus 16 equals 50. 4y equals 34. So y equals 34 divided by 4. 1, 2, 25, 12.5. So CD is 12.5. Add another 4, 16.5. Which I believe is, again, is a typo in the answer key because they just gave you the answer for Y, CD. They didn't give you the answer for PC and didn't add the 4 to it. All right, last problem. The last problem is extremely tricky. The source that I got this from has this starred as exceptionally difficult, and they're not kidding. Okay, So we know that PT is 12 and it's tangent to the circle O. We know that PJ is 8, JN is 4, ON is 4, and we're looking for the radius of the circle, OJ, OT, or any radius that we can find. Now, like we saw on the proof, when we did the fill-in proof here, we're going to have to draw in some segments that aren't in our picture. Okay, and what we're going to draw first is extend PN, PJN until it meets the circle. Okay, when we do that, I'm going to call this point R. We get another radius here. We have a radius, little r. We have another radius here, little r. Okay. How does that help us? Well, we can call, I'm going to do a right angle here, up and down. I'm going to call this x and this y, and that altitude here, we'll call that d. Okay. We're going to now be able to use the fact that 12 squared is equal to 8 times 8 plus 4 plus x plus y. Okay, so over here to the side, I'm going to write 8 times 8 plus 4 plus x plus y, which is equal to 12 squared. Okay. 8 times 12 plus x plus y equals 144. 144 divided by 8 is 18. So 12 plus x plus y equals 18. X plus y equals 6. Okay, which means NR, segment NR, is equal to 6. Okay, how does that help us? Well, y, get that in the right place. Here's JR. Because this is perpendicular to JR, then from R to here, or Y, is equal to half of JR. Right? To this point here. We don't have a name for that point. Probably should have given it a name. But Y is equal to half of JR. Y is equal to half of JR, because I made that perpendicular from the centers, bisect chords. Okay? So Y is equal to half of x plus 4. Sorry, JR is JN plus NJ. Let's write it. JR is equal to Rn plus Jn. Y is equal to half. Rn we just found, 6. Plus Jn we're told is 4. Y is equal to half of 10. Y is equal to 5. So Y here is equal to 5. How does that help us? Oops. Ooh. Back on screen. Okay. X plus Y equals 6. So what's X equal to? We know what Y is 5. So X has to be 1. So this is equal to 1 here. Now we can do a little Pythagorean theorem again. O n is 4. X is 1. We can find D doing the Pythagorean theorem. 4 squared, let's go, D squared plus 1 squared equals 4 squared. D squared plus 1 squared equals 4 squared. D squared equals 16 minus 1, 15. D equals the square root of 15. So if D is equal to the square root of 15 and Y is equal to 5, we can finally find R. After all that, again using the Pythagorean theorem, R squared equals square root of 15 squared plus 5 squared. R squared equals 15 plus 25. R squared equals 40. R is equal to square root of 40, or 2 square root 10. That is a super challenging problem, and I will put this solution up on Google Classroom along with this video. All right, girls and boys, thank you very much. Bye.